All right, for part B, we are going to create the circumcenter, and we're going to do that by creating perpendicular bisectors on each side of a triangle and seeing where those perpendicular bisectors intersect. And then lastly, we're going to go from the circumcenter to one of the vertices and see what do we notice there. So I'm going to do that on the Geometry E tool. I'm going to create a triangle that looks similar to this and then work with it. And so to do this, we are going to start with just creating a triangle that looks similar to the one to the right where we had A, B, C, and D. That looks pretty good. Sorry, just A, B, and C. This is going to be A. And it's not super important we label them, but let's just do it. It's pretty quick and easy. A, B, and C here. And again, just making sure this looks somewhat similar, and it does. Okay. What I'm going to do is create perpendicular bisectors to each side of this triangle. So first, starting with AB, creating a perpendicular bisector like we usually do, which is extending circles, connecting their intersection points. And there is one perpendicular bisector, and I hide the rest so that I'm just having the perpendicular bisector there. Okay, I'm going to do that to side AC. Same thing, using two circles, going to connect their intersecting points. Here's another one there. We'll hide those so that we just have the perpendicular bisector, and we finish up with CB here, connecting those, and we will draw a segment through there to there, and we can see a point of intersection. That point of intersection right there is my circumcenter. Let's hide some of this other jazz, and we'll click here. We'll label it so we know that it's the circumcenter. Okay, and then lastly, it told us in this problem to, right there, create a circle that goes from the circumcenter to out to one of the vertices, and what do I notice? So creating, here's my circle, starting at the circumcenter, out to one of the vertices, and I notice that this circumcenter, the circle starting at the circumcenter, or centered at the circumcenter, out to one of the vertices, I'm touching each and every vertice with that circle. Interestingly enough, what that means to me is that the distance from the circumcenter out to each vertice is the same because they're all radiuses of the same circle. So that means that circumcenter is equidistant to each and every vertice here. So very interesting there, different than the centroid, that's for sure. The centroid is usually the center of the triangle or that perfectly balanced point. Here you can see how the circumcenter can actually move and actually come apart at some places depending on how weird I want to make this triangle. So hopefully that's helpful there for the circumcenter, and then hopefully you are able to now create a centroid and a circumcenter if asked to.